Hello students, let us continue the session on revision in the chapter area related to circles. I had given a question in the previous session for you to try. We shall discuss that question first. That was question number 6. Find the area of the flower bed with semicircular ends as shown in the figure. Here we need to split the figure as two semicircles plus two semicircular ends plus a rectangle. Here the radius of this particular semicircle will become 5 centimeter since the diameter of the semicircular end is 10, so radius will become 5 centimeter. The length is 38 centimeter and the breadth is 10 centimeter. Here area of flower bed will be equal to sum of the area of rectangle plus area of two semicircles. Area of the rectangle is given by L into B, plus there are two semicircles. The area will be half pi r square. This half and half will get cancelled. The length is 38 multiplied to the breadth 10 plus 22 upon 7 into radius square is 5 into 5. Or else I can express this in terms of pi only. That is what I had given in the answer. This will become 380 plus 25 pi centimeter square. Question 7. In the figure 11.7, AB is diameter of the circle, AC is 6, BC is 8 centimeter. Find the area of the shaded region. Here we need to find the length of AB, which is a diameter. Let me consider O as a center. We all know that the diameter will subtend the angle 90 degree at the circumference. Angle ACB is equal to 90 degree because angle in a semicircle, angle subtended by a semicircle is 90 degree. So we can make use of Pythagoras theorem. AB will become the hypotenuse, the square and the hypotenuse will be equal to sum of the squares of the remaining two sides. Let's substitute to find the length of AB. AB will be under root 6 square plus 8 square. This will become 10 centimeter. Since AB is a diameter, the radius will become equal to 5 centimeter. Therefore, the area of shaded region will be equal to the area of circle minus area of triangle ABC. Area of the circle is given by pi r square and the area of triangle is half base into height. In a right angle triangle, if one of the side other than the hypotenuse is the base, one more side other than the hypotenuse will become the altitude. They have given use pi equal to 3.14, so take 3.14 times radius square is 5 into 5 minus half into base into height, 4 times, so we get 78.5 minus 24, which is 54.5 centimeter square. Question number 8. Find the area of the shaded region or the shaded field as shown in the figure 11.8. We can make this figure into a rectangle plus a semicircle. For this semicircle, what is the radius that we need to find? Here the total length is 8 centimeter. From here to here, if it is 4, from here to here, this has to be 6 minus 4, which is 2 centimeter. So this particular thing is the radius. So I have found the radius. The radius is 2 centimeter. So area of shaded region will be equal to sum of the area of rectangle plus the area of semicircle. Area of the rectangle is length times breadth plus area of semicircle is half pi r square. The length is 8, breadth is 4 plus half into pi into radius square is 2 square. So one of the two goes cancelled. This becomes 32 plus 2 times pi centimeter. So since it is in meter, so area will be in terms of meter square. Question number 9. Find the area of the shaded region in the figure 11.9. The area of the shaded figure is nothing but area of this larger rectangle minus this particular figure, which is a combination of semicircles and a rectangle. For simplification, better I name this figure as ABCD, the larger rectangle as ABCD. Inside one, I will name it as EFGH. EFGH. Here, let me identify the dimensions of these figures for the rectangle ABCD. What is the length? They have given it is 26 meter and the breadth is given as 12 meter. There is another smaller rectangle inside the rectangle EFGH. What will be the length in the case of the rectangle EFGH? This will be the total length minus 3 from this side, 3 from this side, and also the radius. We don't know the radius here. Let me name this as R. And how do I find the radius here? The length of GH, is it known? Yes, it is known. The length of GH will be equal to this 12 minus 4 and minus 4. So 12 minus 4 minus 4, totally it is 8 meters. So the radius will be half of that. Sorry, it's not 8. I made a mistake. This is 4 because 12 minus 4 is 8. 8 minus 4 is 4. So 4 meters divided by 2, the radius will become equal to 2 meters. This is for semicircle. So the length of the rectangle EFGH will be 26 minus 3 minus 3 minus 2 times the radius. So the length will be 26 minus 3 minus 3 minus 2 times 2. So L will become equal to, this is 4 plus 3 is 7 plus 3 is 10. 10 has to be subtracted from 26. We get 16. So 16 meter is the length. Same is the case with the breadth. In the breadth, I need, no, same is not the case. It's directly minus 4. So it is 4 meters. Now the area of shaded region will be equal to area of rectangle ABCD minus the sum of the areas of rectangle EFGH and 2 times area of semicircles. The area of the rectangle is 26 times 12 minus, within the bracket, area of the rectangle EFGH, it is 16 times 4 plus 2 times area of the semicircle is half pi r square. So it is half into pi r square. Pi value I'll retain as it is, into r square is the radius square, that becomes 4. So 2 and 2 will get cancelled. We'll be getting the result as 312 minus 64 minus 4 pi. So 312 minus 64 will be 248 minus 4 pi times meter square. So the area of the shaded portion is 248 minus 4 pi meter square. Question number 10. Find the area of the minor segment of a circle of radius 14 centimeter when the angle of the corresponding sector is 60 degrees. So let me draw a rough figure connecting this particular question. Imagine that it's a circle with a center O. When the angle of the segment is 60 degree, here this becomes radius. So these two angles also will be equal. You will find that these two angles, they are also 60 degree. So it's an equilateral triangle. Now for the segment, I am going to shade this part. They have given the radius of the circle is 14 centimeter. Here angle A will be equal to angle B. This will be equal to angle AOB, and all the three angles are equal to 60 degrees. Now to find area of the minor segment, I require area of minor sector minus area of the triangle. Let me mention that area of minor segment will be equal to area of minor sector minus area of triangle AOB. Now from this we can say that it's an equilateral triangle, so area of minor sector is theta upon 360 degree multiplied to pi r square minus the area of equilateral triangle is given by root 3 by 4 a square. Now let's substitute. The angle is 60 degree upon 360 degree multiplied to 22 upon 7 into radius square is 14 times 14 minus root 3 upon 4 into the side is also radius, which is 14 times 14. Here certain things are common. Let's take that as a common thing. So we'll be having 60 by 360 is 1 upon 6. This will be 3 times 11 times. 14 into 14 I can take it as common. So 14 times 14 I'll take as common. But the remaining things are 11 upon 7 3s are 21 minus root 3 divided by 4. Am I right? Yes. Here this will be 196 times of 11 upon 21 minus root 3 divided by 4 centimeter square. Further, if you want to simplify, you should take the LCM over here, then you should simplify. This is one approach. Another approach is, what we can do is, here we can simplify. Let's simplify that part and let's check it out. I'm going to simplify in a different method. Let's do that. This will become 6 times 7 2s are 14, 2 3 times. Now 2 times, 2 7 times, one more 2 7 times. So what remains here in this part is 22 multiplied to 14 divided by 3, and this side we get 49 root 3. Times 14 is 308 upon 3 minus 49 root 3 centimeter square. If you want further calculation, we require root 3 value, it's 1.72. So you can substitute 1.72 times 49, and this has to be 308 upon 3, and roughly we get the answer as 17.796 centimeter square. In the examination, if you don't get more time, you can keep the answer in this simplified format. You will get the answer marks for that. Question number 11. Find the area of the shaded region in the figure 11.10 where arcs are drawn with centers of A, B, C, D intersect in parts at midpoints P, Q, R and S of sides AB, BC, CD and D respectively of a square ABCD. Here, since it is a square, the angle is 90 degrees. Why do we require this angle? We require this angle to find out the area of the sector. Here, the radius of the sector is 12 by 2, which is 6 centimeter. So area of shaded region will be equal to area of square ABCD minus area of sectors. How many sectors are there? There are 4 sectors, so I'll multiply this with 4. Area of the square is side square, which is 12 times 12 minus 4 times of area of the sector, which is 90 degree upon 360 times of pi r square, which is 3.14 into radius square is 6 into 6. This becomes 4 times. 4 and 4 will get cancelled. We'll be getting 12 into 12. From this we can take 6 into 6 as common. So 6 into 6, when it is taken common, you will be left with 4. So 4 minus 3.14. So 4 minus 3.14 is 0.86. 6 are 36. So 36 multiplied to 0.86 is 30.96 centimeter square. This is the area of the shaded portion. With this question, I'll end today's session. We shall take up some more questions in the next session. Thank you.